Good morning. I'm Jez, and I'm going to be running a little guide on making a game from scratch in Nim using the Nico framework. I'm going to be making a CGA game for the CGA Jam. Using Nim programming language, which I really like. It's high performance garbage collected, compiles to C, C++, or JavaScript. Runs everywhere. Looks nice. It's quite readable. It looks a lot like Python if you're familiar with Python syntax. It's very easy to pick up. If you're not, well, I think it's pretty easy to read. Yeah. So to get started with Nim, what you do, easiest way to install it is go to look up choose Nim, just Google choose Nim, and you'll end up on this page. And look for the installation instructions. So if you're on Windows, you can just download. And if you're on Unix like me, just copy that and open a terminal, paste that, and run that. And I actually already have this installed. But yeah. Alright. Warning, blah. That's fine, I'm using that version. Alright. So choose Nim is installed. You must now show the nimble bin there is in your path. Let's place the following line and then profile.c. Alright, so you can do that. Echo. I shall see. Make sure you use 2 arrows to a pen. And then close terminal, open again, and choose Nim. Alright. Choose Nim. Let's get the latest version of Nim. We can say choose Nim. 17.0, I think. Switched. Okay, if you don't have it already, it will install it for you. It will download and build it. I happen to already have it. Cool. So if you type Nim, you should get that. That version. Cool. Let's get going. CD programming, CGA Jam. Alright. I don't know what's in there. I started making some stuff, but I don't think it's necessary. Clear that out. And we want to make sure we're going to be using Nico, which is github.com ftsf/Nico. The Nico game framework. It's very similar to the Pico 8 API if you use that. It just works on top of STL2. So, 16 color bitmap graphics. Yeah, I've made a few games with it already. So, install Nico. Install. Aha! This is a problem. I haven't published it on Nimble yet, which I will do shortly, but for now you can get it here, copy that, and on here, run Nimble install. And it will install it for us. I already have it, but right, it's now installed. If you want to see the examples, you can do just write Nimble examples. It will build the example programs. It's pretty quick to build. Cool. And examples directory. sliders, and platform, which is a little platform type game, sub making. So the code for those is all included. If you want to play around or use it as an example to get started. Alright, so I'm going to get rid of that, it's already installed. So to get started, we'll do source, do assets, that should do it. And I'm going to open up source main. It's going to be our game. Okay, this thing is import Nico. And we need to do some setup for Nico. If we look at one of the examples, let's look at paint out. So this is the actual game. But if we go to the end, we'll see the initialization code that we'll need. Nico.init. And here you put your organization name, so Inkbox, and then the app name, which is going to be called CJ Jam for now. I'll change it later. The reason it needs that information is for storing the configuration. It knows which directory to use. Nico.create window CJ Jam. And let's start with 128 for 128 pixels and 4 times scaling. Nico.run, and then we give it 3 functions: the init function, the update function, and the draw function, which we haven't created yet. So let's do that. So these are functions that we need to create. So we'll do pin proc is how you say it's a function, the procedure, and implementation. For now, it's just going to go echo init game update dt float, which is how much time there's elapsed since the last one. Print out dt is proc game draw, and what are we doing this one? We can clear the screen. We can print hello world at roughly the middle of the screen, go up a few pixels and go, let's say, 42. We should set the color. So by default, Nico uses the Figure 8 palette, so 16 color palette. So let's CJ, and if we run nim c Java source and build it successfully, and it's printing. We're not seeing anything on screen. The reason for that is, well, I can't see that anymore. I'm going to get rid of those prints. I'll just put that discard, which is the same as pass in Python, just means you've got an empty block. So I think the problem is that it's not loading the font because I haven't included it. So I'm going to copy that from assets font, assets, and my command line for building, I'm going to specify the output file. Cool. And now have it printing hello world. uppercase. It's pretty easy to read. So the font is also based on the Pico 8 font. And alright, so for the CGA gem, you're going to need to use the CGA palette. So I believe that Nico has a CGA palette. Load palette CGA. So Nico.load palette CGA, which will give us the 4-color CGA palette 1, I guess, which is my favorite palette. So color 1, there's one more color 7. Zero should be black. 1 should be blue. Yep. So we can say around 1, 2, 3. Get it washing very quickly. Alright, let's get rid of this text and let's go circle. I'm going to have a thing that moves around, so we'll set var x equals 64, y equals 64. Radius. Let's make this blue for now. So we should have a blue circle in the middle of the screen. And we can't do anything with it yet. So let's have our update function so we can move it around. So if button to left x minus equals 1, to right, x plus equals 1, button PC, y minus equals 1, button PC down, y plus equals 1. Okay, now we got a little ball around. Not very exciting, but start of how we make a game. Alright, let's get their movement, making it nicer. Make these a floating point number instead. I'm just going to put in the velocity. So instead of this, we're going to change the velocity and make this a bit slower. Now we have a bit more smooth motion going on. We'll keep going once you press it. We're not slowing down ever. We can add that pretty easily. Just do x times equals 0.9. When I let go, it'll stop. So the x is for the horizontal position, y is for the vertical position, xv and yv are the horizontal and vertical velocities. So when we press the left and right key, we adjust the x velocity. When we press up and down, we adjust the vertical velocity. And then we update the x and y position based on the velocity. And then we reduce the velocity over time. So multiplying it by 0.95, so it'll get lower and lower over time. Okay, if we open it up, we're going to start a sprite, and which is an awesome little pixel art editor. I'm going to create a 128 by 128 image, index color, set palette, CGA, CGA. So the colors we're actually going to be using are this one, this one, this one, that one. So let's draw a little sprite. Let's start with something simple. Alright, what were the themes? History repeats, always faster, gravity, Wild West to Westworld. I feel like making something simple, maybe a shoot 'em up spaceship game. Work with always faster, gravity, maybe. Not into the Western theme, really. History repeats. Whatever. I'll justify the thing later. Let's make a spaceship. Blue, white. Try something. Alright. Like a spaceship, I guess so. Alright, save it. Call it spreadsheet. Doesn't matter what you call it. That's what I usually call it. I'll move this to a different desktop. Okay, so now instead of our sock fill, let's do in it. To load our spreadsheet. SPR, which is the command to draw a sprite, and I want to draw a sprite. That's 0, this will be sprite 1. I'm going to draw it X, Y, and it's 2 by 2 cells wide. And, alright, let's try that. Alright, we have our spaceship. Currently, it's drawing it. So drawing it at this coordinate is, so whatever that position specifies that coordinate, that we want it to be in the middle. So x, draw it x minus 8. 8 or 7, since it's an even number size, it's not going to be exactly the middle. I can currently go off the screen if I'm not careful. So let's fix that. So after increasing the position, you can say if x is less than 0, if x is less than 0 equals 0. If x is greater than 127, then x equals 127. Haven't fixed up the y-axis yet, but yeah, I just wanted to show we need to adjust that. So add a bit of padding. So x plus 8 is great. Let's do 19. And that's right. Okay. We can do the same for y. Cool. We have our spaceship. And let's make it so we can fire some bullets. Bullets equals of type seek. Let's define a type for the bullet. Type bullet equals object. What else do we need for a bullet? That'll do. Now we can extend it. So bullets is a sequence of bullets, and during game init we'll say bullets equals new seek. If button, so the A button, which by default is Z, Z if you say it that way. We'll do bullets to add. Let's make a function to create a new bullet. Actually, I don't want to do that. Add bullet x equals x colon x. So that's the player's position. So 0, y is -4. So we also need to draw the bolts. So for bolts, I'll just use circles for now. Clear the screen for spaceship. Draw bullets. Clear the screen. I'm forgetting to update the bullet's position. So we can create bullets now, and we hold them up and down, but they don't really look like bullets because they're not moving. So we set the velocity, but we're not actually doing anything with it. So bullets, bullet dot y as opposed to bullet dot y b, same as we're doing for the player. Currently, we're not updating the x position, but may as well do that too. So this won't work. Oh, well, one thing I may not have saved it. Yeah, that's we'll get this confusing error message. Line 48. Type mismatch. Got float. So the problem is that we need to make it says for a var type a variable needs to be passed, but bullet y is immutable. Because when we iterate through bullets, the bullet we get is one that we're not allowed to change. We have to say m item, which allows us to change it. So we need some spacing between our bullets because they're happening one a frame at the moment. So let's add in a timer to say bullet timer equals 0. So this will be the number of frames until we can fire the next bullet. Bullet timer equals 8. So it has to wait 8 frames before we can fire again. And bullet timer equals 0. Bullet timer is greater than 0. Bullet timer equals 1. Plus looking the stick. That's better. Might be able to see the bullets coming. They're starting on top of our spaceship. We should probably move them up a little bit. -4. Another problem we have is let's print bullet start land. So that's now printing the number of bullets on the screen. Well, number of bullets in the game. And notice that it doesn't actually go down at all. So that's going to be a problem. Eventually, if we play for long enough. What we can do, we want to say it should be destroyed. Cool. So if dot y is less than 0, bullet dot should be destroyed equals true. And now we can say bullets dot keep if a bullet dot should see the number of bullets is staying at a reasonable number, which is the number on screen. As long as our bullets are always using the screen at the top, it should be fine. Alright. It's already feeling alright. Alright, let's add in some baddies. What do our baddies look like? Make our baddies pink, red. This looks like. Let's do some kind of circly blob thing. Blob ship. Missing blob. Looks like stingray or something. Stingray ship. Very cute, but not very menacing. Square. I don't know. That'll do for now. Alright. Seek enemy, which we haven't defined yet. So enemy project. It's going to be pretty much the same as this. We could use inheritance or something to. Yeah, let's. Yeah, I'll keep them second. Okay, and to draw the enemies. So draw bolts on the top. Draw enemies. Number 0, 1, 2, 3. Right, 3. So it's 1, 2, 2. And to X and to Y. Alright, now we need to actually add some enemies. So we're going to, let's just, what point should an enemy appear? Let's add a timer. Counter timer. Every 3 seconds. Time -1, time 0, time 1000. Make it a random number. between 1 and 3 seconds. Then we want to add a new enemy. Start add enemy equals 128. Equals at the top of the screen. So minus 3. To move downwards, so that is increasing. Okay. Let's see if that works. Undeclared identifier enemy 73 and ease. Not seeing any enemies. Why not? Not targeting. So change this to number of enemies. Make sure that's going up. And it's not. Let's point out our enemy timer. The dollar sign means convert it to a string. Okay. That's obviously way too long. It's not milliseconds, it's frames. So that's 60 frames a second times 3. And this will be 60 plus 120. Yay. We have enemies appearing. I can't shoot them yet. I can't crash into them. And they're also not disappearing when they go off the bottom of the screen. Alright, let's see if enemy dot 1 is greater than 128. Give a little bit more space. 150. That should be destroyed as true. And okay. For bullets and bullets. If we can check the distance between each of the bullets and the enemy. Here, let's see, what distance equals square root of x minus x 2. Bullet to y minus y to y 2. Distance is less than 4. That's how big our bullets are. Then enemy dot should be destroyed as true, and bullet dot should be destroyed as true. And we can break our loop. Because we're saying it should be destroyed, we'll need to make these modify our loop. Destroy that. No square root. I need to import math. distance should also be a bit higher. It says the bolt's destroyed, but it doesn't seem like it actually is. Do we actually get rid of them? I actually need to get that. I'm sure. It's better. Okay. How about we make the enemies shoot back at us? So we'll give the enemies a bullet time as well. And we'll have a thing bullets to see if they're a friendly or enemy. So when you create time goes around 30 and 60. 60 plus. So if they're not destroyed, at least half a second. And let's start to add bullet. X. And Y equals. You go downwards and faster than the enemy. And true. And where are we drawing? Bullets. So set color. If bullet enemy. See if that works. Well, they're shooting, but they're shooting themselves. So we only want it to destroy them if the bullet is not an enemy. So if bullet, but should start the bullets a little bit lower. Currently they're appearing in the middle of the enemy. Let's make them appear at the bottom. Enemy. Right, so enemy bullet. Dot y plus 8. We could also make them come towards the player a bit, but I think it's fine for now. Let's also make the bullets flash. So my bullets are red. I think our bullets should be white. And the enemy bullets should be red. But I'm going to close this and move this over here. Let's see more about code. It's very easy to note, not much challenge. At some point we also need to add in a way to for the player to get destroyed if we get hit by a bullet or an enemy, and then a way to restart the game. Let's do button P, PC, and we'll restart the game. Go through all the bullets, aren't we? Distance was good. Let's add in a distance. Float. Distance between the bot and the player, and the distance is less than 8. Don't show destroy is true, and we don't have a way to kill the player yet. And over is true. Over. Right. Okay, blah blah. I did a game over already. So the C button to restart is working, except we need to say game init. False. We should reset everything. Enemy time equals 60 times 3. Reset. No, things we need to reset. X equals 65. Getting hit by iron bullets. Same problem we had with the enemies. Enemy. So only bother checking if you hit the player if the bullet is an enemy bullet. We're not killing ourselves. Right. What should happen? So I want this to work. Regardless if it's game or not. Player can't move if it's game over. I think everything else can keep going. Cool. We can restart. I think we fire too fast. It's going to take the bullet time player's bullet time. Let's make it 30. So we can fire 2 bullets per second. Assuming it's running at 60 frames per second. That's going to be a lot more challenging. And then we can get power-ups and stuff which make us shoot faster. It's already a much more challenging game. Let's make the bullets flash, so let's put in another variable frame equals 0. And every frame plus equals 1. Oh, okay. And we draw the bullets. If frame mod is less than 5, two else's. If else. Good. Now bolts are flashing. Makes them stand out a bit more. For me, I'm about to sneeze. How do I stop? Alright, I have sneezed. Alright. Sorry, I got distracted playing the game. It's already surprisingly kind of fun. Alright, what should we add next? Maybe some little power-ups or points that pop up when you kill enemies. Points can pop up. Let's have a score equals 0. And new type of thing. New type. I call them. Gem. And our gems will have a time to live before they disappear. Right, bullet gems. Gem.ttl is 1, if gem.ttl is less than 0, then gem.should just write true. Let's add in a symbol for our gem. Crystal shape. Kind of like that. Now we need to draw our gems. Draw them first, because they're the least important thing. And should be 5, I think. 0, 1, 2, 3, 4, 5. Yes. So 1, after add gem x. And we'll shoot them out in a random direction. TTL equals 16 times. They got 5 seconds to grab the gem before it disappears. Now let's create a few of those for 0. See if that works. Gems exploding everywhere. Can't pick them up yet, and probably that movement. It's a bit weird. They're also maybe too big. Let's make them a bit smaller. Put them into a single grid cell. There's our draw gems. So one by one, and it's a bit better. And they should probably slow down over time. Too much. That's nice. The other thing I want to do is make it so it actually feels like we're moving. So let's add camera. Let's see what. So our camera will move. We won't have a lot of sense of movement yet. We could add a star field or something later to make that more obvious. So if not, game over. TY. Okay, so stuff's happening now, except that's cool. So before we draw the UI, we need to set camera back to the default. And where is our player movement? CY. I'm also going to do the same to Y. And a bit where we detect if we go off the screen. To get rid of CY. Looks odd when it's 0.5. So, excuse me, 1. Doesn't let me. So our bullets also need to be adjusted so that they can exist beyond that point. Let's see. I'm really terrible at maths. I'm sure. What did I do here? So let's see why. CY plus 150. And then we'll create new enemies. Then CY minus CY. So now we're moving a lot faster because everything is moving. So we can slow the enemy down. And enemy bullets can go a bit slow as well. The enemies are still moving too fast. Yeah, it's right. Let's make it so we can pick up the gems. And instead of printing this stuff, let's just print out score. So that's what we really care about. Next one, change of X, change of Y. Distance is 8. Gem dot should be straight true, and score plus 0 is 100. Oh, I didn't get to test that time. It's a bit fast to point out. Well, I'm getting points, but it's not destroying the gem. Why is the gem not being destroyed? Because I haven't added one of these. So it doesn't care. Gems. Cool. Score, bullets, deaths. But I think that's about the speed of the enemy should move, so let's make these minus 0.5. Yeah, it's better. That's nice. Cool. Let's make our bullets look better. Right. Archy bullet. Right. And I think the enemy bullets being circles is fine. I'll just put this at 0 because that's easy. Draw bullets. So if bullet.in is str 0, bullet.x, bullet.1 minus always number 2. Else to bullets. Let's make it flash as well, so we can use the pal command to adjust our palette mapping. So this is ignoring this because this white is palette 3, I'll map it to 1, and then also back to 3 if frame mod 10 is less than 5. Okay. Gems should disappear after a few seconds. Yeah. Let's make them flash just before they disappear. So if gem.ttl is less than 60, if frame mod is less than 5, continue, which means we'll skip the next call. So we should see them flicker before they disappear. Excellent. What else? Let's add in a power up. What would a power up look like? Or crate, maybe? Does that look like a power plus? That looks reasonably power up-ish, I guess. Add a new type. Power up. Okay, we have power up type now. I feel like I'm redoing a lot of the same thing. refactor this to make it so I'm duplicating less code. But I'll save that for the next one, next tutorial. And let's make our power level plus equals 1. I haven't defined power level yet. So power level 1. And power level is 1. So when we destroy the enemy, add gems, and if rand 10 equals so there's a 1 in 10 chance. Add a power up. So 2 power ups. And let's make it so when we increase our power, our bullet timer goes down. So that's power level. So 54 power-ups. Declared identified power-ups. Let's put that should be power-ups. I realized the problem. I'm not drawing power-ups. So even if I get one, I won't see it. So draw gems. Draw power-ups. Power-up and power-ups. Power-up. Do the same kind of thing. And power-up is 6. Should probably make them flash or something so they stand out. Yeah, good power. It's not really noticeable. Let's see. Power level. 9 times 10. Might be too much now, but at least we'll be able to tell. Get it. This time for sure. Should get 1 in 10 chance. So if I kill 10 enemies, that's a pretty good chance. Wow, I'm really bad at this game. Yeah, you got one. Yes, definitely a lot faster now. Let's have one more firing speed. need to make the gems and stuff bounce off the side of the screen when they go off. Let's move gems. So if gem dot is less than 0, gem dot xv equals gem dot equals minus gem dot xv. Gem dot x equals 0. Gem x is greater than 1.7. Gem should hopefully bounce off the screen now. Like it did. There's an enemy near the side. Yeah. Power up. Yeah. Cool. Alright. Well, I think that'll do for the first part of this tutorial on making games in Nim with Nico. Hope you enjoyed it. Let me know if you've got any questions. If I haven't explained anything very well, happy to go into more details. Alright, enjoy!